So welcome everyone. Today's session, we are showing how to use ARM for greenhouse studies. So really, ARM software, kind of its bread and butter is crop protection is where we got started. That was the original target for Steve Gilling when he started the software, and it grew to really cover all of the agrochemical research is really where the heart and soul of ARM is, but it's really ARM's used worldwide and has really, with its flexible structure, has supported all different kinds of research. And so we wanted to highlight one that maybe gets forgotten as far as realizing ARM can certainly cover greenhouse studies as well. So we kind of just want to show there's some differences, of course, in how things are done, how things are performed, what certain things are called. So we're hoping to kind of highlight those differences and talk about how they can still, a greenhouse study can still be performed and recorded with ARM. So as I mentioned at the very beginning, questions and comments are appreciated, whether you do it here in this session when we're live, or feel free to reach out to us if these examples we cover don't quite apply to your type of research. We'd love to have a crack at trying to make it work. As I was preparing for this webinar, we spent about an hour and a half, Michelle and I did earlier this week, prepping just one example, trying to figure out what's the best way to put this into ARM. So we'll kind of talk about the strategies of really kind of a translation process, if you will, kind of comparing it, how things are put in for the field studies versus, well, we just put it in a little different because things are a little different in the greenhouse study. So with that, let's dive in. And I'm just going to switch to my ARM. Don't have a lot of introduction or theory for this session. I really just kind of want to create a protocol, and we'll talk through the different steps of setting up a protocol, and what might be different in a greenhouse protocol. Then we'll also step into the trial map a little bit too. So let's just start with the new protocol. And as you're setting things up, kind of the same rule applies for the new protocol in a greenhouse study. We do have a few options for the study definition that sets up which fields and pieces of information will be put in, are available for us to put in the trial. And in almost all cases, the GAL7 is the way to go. Basically, if there's any chemicals involved, you're going to want the GAL7. The one most common scenario that you would choose something different is if you do have a variety study. So no chemicals involved, just strictly a variety or seed study that you're doing. That would be one case where this G seed would be a better choice, perhaps. Essentially, they're very similar. You still have treatments editor, you still have the protocol description, assessments, but really there's less information in the G seed because we don't have any of the mix size and the spray volume and all those application related fields of mixing up the chemicals. So all of those are kind of dropped out, and there's some naming differences. Instead of treatment name, it'd be entry number or entry name, things like that are just called something different in the G seed. So if you're doing a variety study in the greenhouse or wherever, the G seed would be maybe a simpler, easier choice to use. You certainly could still accomplish it in the GAL. That's totally possible. It'll just be all those extra components that you don't use. So when in doubt, GAL is our friend, and that's the one we'll use today. So I'll say finish, and now on this new protocol, dialog here, I want to enter into the protocol settings. So first up on the general tab of the settings, of course you have the replications. That's standard in any research here. But the next one, the treated plot size. You'll notice, of course, ARM calls it plot, but we also usually reference experimental unit because, of course, here now in a greenhouse study, they are not typically called plots. It's going to depend on what your research is. Perhaps it's a pot, maybe it's a petri dish, whatever scale or what type of study you're doing. It's going to depend, going to vary. But here we need to mark down the size of that experimental unit. In some cases, this might not technically matter. Within a typical fungicide study out in the field, of course, the plot size is very important because we need to know the area of the field in order to know how much to apply, how much of the product to apply. Well, if we're just going to be dealing with a single plant that's in a pot, something like that, it's less common that the calculations are going to require an area at all. So to some extent, this matters a little less as far as getting calculations right. And typically I say then just kind of rough in the area of whatever that individual unit is. You'll notice in our list, we do have centimeters and inches. So if it's a 4-inch pot that the plants are in, maybe just 4 by 4, or if it's a circular 4-inch thing, or if it's a very small little petri dish, maybe it's only a few centimeters. But I try to just put in roughly, the area of whatever container is going to hold that experimental unit. That's about it for this section on the general tab. Moving over to the design. This one here, we can really get to highlight some more of the different design choices we have in ARM. In field work, it's pretty much RCB or die. That's far and away the most popular is the randomized complete block. But here, I think in the greenhouse now you have more choices, more control maybe of where things are placed and how things are done. And I think we can kind of dive into this toolbox a little more and have some more practical options of what design to choose. And so I would imagine the completely random design, or the CRD, then would maybe be more common than the RCB. For the RCB, thought of why it's always used in the field trials is you don't have total control over the field. You might be able to select a decent area, a decent part of the field to put that plot down, but you still only are kind of limited to what is there. And oftentimes there may be a gradient that you're trying to anticipate for. If we just have some simple pots that are in a greenhouse now, we have a lot more control over that, and there is fewer outside sources of error, if you will, that can affect things. So now we can simply run a completely random design because we can just pick and choose where things are placed, and we don't have to have any blocking structure. So that one I would imagine would be a better choice. And the nice thing is you do gain some statistical power at the end of the day, considering the randomness there compared to if you had just taken the default of the randomized complete block and then the blocking made no sense. So it's definitely to your advantage in a greenhouse to run the completely random when there is no not necessarily a gradient involved in the study. A lot of these other options here, Latin square, lattices, things like that, are all more complicated blocking structures. So I think those are probably less common in a greenhouse, but are available nonetheless if you were choosing to do that. The other set of designs that I think are definitely applicable in a greenhouse would be the multi-factor designs. These last four in the list are all multi-factor designs. And so here, I'll just choose one of them to point out that it's really the arrangement of treatments that you have. You may want to use kind of a multi-factor look at the treatments. So the example I'll kind of work on today as we fill in this protocol is a wheat study where we have two different varieties of wheat. One is resistant to the Fusarium scab, and the other is not. And we want to see if that, how that variety performs, kind of side by side. Does it actually work? Is it actually going to resist that? And so we have those two varieties. And then for each of those varieties, we want to test various levels of infection. So we'll have just a spray that we want to spray on its various concentrations of that Fusarium and see how well the variety stacks up. So we really want to do all combinations of the two varieties and those different concentrations. And that's really a factorial design when you want to do all combinations of this and that. You end up with kind of the multiplication, if you will, of every combination of those two levels, we call them. And so that's what we would fill in here in the design is the main factor, factor A, and then factor B. And so in my case, I'm going to choose the concentration to be our first one, and maybe we'll have 4 levels. I have a untreated, check, low, medium, high as the different concentration levels that we want to perform, and then we'll have it on 2 different varieties will be what we want. So in the end, we'll have 4 times 2 or 8 unique treatments. But that multi-factor approach is very useful for design, and then also in the analysis in getting to see how the varieties stack up against each other. You can also see the other cross section about the concentrations would stack up against each other and things like that. So laying that groundwork there on the multi-factor, wanted to highlight a new development that came in just within the last couple of ARM updates. Previously, we had just one factorial design, and it was an RCB factorial design. So there was blocking done within that factorial. Perfect. The request came in for greenhouse studies specifically was where this came from, to say, hey, that same idea that we had up here, the RCB versus CRD, can we do that with the multi-factor as well? Because we don't have any blocking. There's no reason we have to block anything here in our greenhouse, but we do want to have that factorial arrangement of treatments available to us. But the design of where the plots will go has no blocking. They can exist anywhere on the bench. So that now we have a factorial CRD. And it behaves the very same. It's that same setup, arranging the treatments the way you would want them to be. But then when we get to the trial map, the plots themselves, they can be anywhere. There's no blocking pattern to them. Kind of on the flip side of that, so maybe you have perfect flexibility in wherever those experimental units can be, maybe there's a case where you actually have to put them in a certain order. Specifically in this case, maybe that concentration will want to arrange the pots so that each of the concentrations are next to each other. Thinking of here, we're going to spray the mixture onto the plants. We've got a set of untreated where we're just going to spray just water on, and then all the way up to to the high level. We might not want a high level right next to a untreated check for worry of carrying things over. So if that's the case, we really need to keep all of the untreated check together in a line, maybe on that tray, and then then kind of slowly move on from there and keep each set of concentration next to each other, or whatever other research you're doing. If there's a reason you need to keep all of the one type together, maybe it's the way you have to apply it. There's no other way to apply it all then in one straight go. Maybe it's a lighting. I think I worked with one company that was doing lighting, a certain frequency of lighting or something, and how that would help a plant grow or something. So again, you'd have to have every plot, experimental unit that has that one particular type of treatment needs to be next to each other. And that's where the split plot comes in. So same arrangement of treatments, but now when we get to the trial map, we'll see groupings of, in this case, so it'll be groupings of your factor A level. And so that's why I chose the concentration here in my example to be factor A. When we cycle around to the trial map kind of towards the end of the session, we'll see that again, and we'll come back to that trial, and we'll see the impacts of choosing split plot on the trial map. We actually also will dive in even more to the split plot in our next webinar as well. So if we kind of run out of time, we'll have more discussion on the split plot. So that's the design tab. Just moving on a little bit quicker here in the settings. The treatment tab, pretty much the same usage as a regular study. The application we'll come back to. We'll do that in the protocol description, and then the layout, that's really related to the trial map. So we'll try to cycle around to some of those sections again as we move forward. So I'll say okay here to keep those settings, and then one more okay will get us into the protocol. All right. So next step here is just maybe looking at the protocol description. Not a ton of major differences in kind of this initial planning part of the protocol description of we kind of covered the plot area. One thing that I think is important would be to specify the experimental unit. So that's one where in field studies, it can be taken for granted. Maybe there's a lot of times people don't even fill it in because it's a plot. That's the term everyone uses. But certainly being able to define specifically what the experimental unit is, I think is good, especially in a greenhouse. You have that opportunity to draw attention to that. And you can see that there's a lot of different options. Here's that 4 centimeter pot, for example, or more generically, if you didn't want to specifically say what size it is, perhaps that's the route to go. But you have a lot of descriptive options for really specifying what is that experimental unit. There is, I think there was one other field here. The was it site type here? I think also was a way to specify a greenhouse Yep, so there's a greenhouse option here in the site type. So that would be another opportunity to have that, stand out just as you're describing the study. But otherwise, objectives, contacts, things like that are all pretty much the same in a greenhouse compared to a field type of study. As we make over to the application, of course, now this is where some differences definitely start to show up. Before we dive too deep into the applications themselves, I want to point out a function of ARM that can make life a little easier, especially for studies that are quite a bit different than the typical one per se. And that is to leverage your view. So as you create a protocol, there's a lot of fields here just in this table for application. There's a lot of information. And something like ground speed. Well, if I'm in a greenhouse, we're not talking about any equipment driving through a field and how fast it's driving. We'll never, ever use that. So you can hide information, hide these prompts that you'll never use so you don't have to see them. And all you have to do is right click in the value that you don't want to see, and you can hide current field. And there the ground speed is hidden. Even if we had information in there, it's not going to delete the information. We're just controlling what ARM shows us. And as I did a moment before on your properties panel, there's a list of hidden fields. So when you take them away from your view, it simply just marks it as hidden. And so you could always, if you needed to, bring back that ground speed and put in that information or see what is there. So that's one thing, as maybe even just that first time using ARM, it seems overwhelming because there's just tons of information and none of it, most of it doesn't make any sense for what you're doing. That's okay. Use the right click, hide those fields, and then ARM will remember that those are hidden. Or if you open your view options, you can save that view. So maybe sometimes you're working in the greenhouse, maybe over the winter months, and then when it warms up outside, now you're back out in the field. You can save different views. So as you go through and hide anything that is never going to be used in the greenhouse, then save that view as your greenhouse view. And this is saving, this view is the protocol description sections, as well as the header. So all of these different tabs within that protocol description will remember exactly what you see right now and what you chose not to see. And we'll give that a name here, so that way it's very easy to load. So now you can work on other types of studies. These are all the different views that are saved. I can look at all fields, so everything now is visible. And then when I open up a greenhouse study and I want to kind of narrow my focus, it's just a matter of in that views, click on the view that you created, that you gave a name, and it'll immediately put back the fields as you had hidden them before. So that's a trick to simplify what you're looking at, especially, like I said, if you're not doing a field study, there's probably a lot of things here that don't apply. I would say for pretty much any study you're doing, there's going to be a lot of things in ARM that don't apply. There's so many different types of research that's done in ARM that no one single study will ever use every field that's in an ARM screen. So make it easy on yourself, less overwhelming, and hide those things that won't be used. Backtrack just a second for a question about the trial establishment climate zone. So really in a greenhouse, then you would not have a climate zone, or wherever the greenhouse is, it would not matter. We do have a not applicable I think that would probably be the choice to make for a greenhouse. You know, from a technical standpoint, that greenhouse is in some physical location that has a climate zone, but that climate zone is not applicable, essentially. And that would help to ensure that anyone that looks up your trial GPS doesn't try to fill in a climate zone. Oh, I found that you're in South Dakota here. Let's find out the South Dakota's climate zone and I'll fill that in later on down the stream. Make sure that doesn't happen by choosing the not applicable. So that's a great suggestion there. Thank you for pointing that one out. All right, so moving on to the applications. As we said, hide some of these fields that just never will matter, that won't ever be used. I do want to point out, let me hide this minimum mix that we really don't need to see. 3 fields that, at least in the field studies, we spend a lot of time in training, you know, introducing ARM, but we spend a lot of time talking about these fields as they're setting up an application for the first time. I'm talking about the application amount and the mix size. And I'm going to use this little tool button here to bring up the mix size calculator. This might look a little familiar. It's basically the same tools that we saw in that settings dialog on the application tab. So it's really the same thing. It's nice to fill in for the particular application code that we have. So that's why I like to show it here. But it does have the same options on that settings dialog as well. So in the field study world, you know, we always talk about the application amount being the amount of carrier, it's typically water. You're gonna put your chemical in water and distribute it on a per area basis out to that plot size. And again, that's why it's so important to fill in the plot size. And then we spend a lot of time talking about how we can calculate the right mix to make sure you cover that area. Well, none of that matters in most greenhouse studies. As we said, it's not an area of the plot. In our example here with our variety and in concentration study that we're walking through, we just are going to make we just want to spray the plant that's in our pot and until it's wet. You know, we don't have a specific area that we need to cover, and we don't have a particular rate of that product and carrier per area. So that really doesn't apply in our case. And so when that happens, when the application isn't being done in that fashion, or maybe your product is undiluted and it's going on directly to the experimental unit, then you can put in 0 for the application amount. And I just leave liters per hectare is the first one chosen, maybe in the US, gallons per acre, whatever you like to use. But really the key is just put in a 0 and leave the unit be the default. And that's a simple way. As you can see, then the calculator here, as it tries to take in the plot size, application amount, oh yeah, the mix size is 0. There's no mix size here if we're doing a undiluted application. So that's a simple way to say, yeah, this doesn't really apply. Otherwise, a value in there, it might try either be confusing if we just left in the default 200. That might cause confusion of how am I supposed to do 200 liters per hectare. So a 0 just kind of ends the discussion, but having something in there then makes it clear that that's the case, that there's nothing. There are a couple of application amounts or that could play a role depending on the research here in a greenhouse. So I did want to just point out there is a milliliters per liter. Oops, my mouse moved just a little. Milliliters per liter. So that one could be used in, kind of a concentration type of application, perhaps, of your milliliters product per liter of your water that's being sprayed or being applied to a liquid. The other one here would be milliliters per item. So we'll get to the treatment editor here next, but if your product was, if you were applying the product, maybe the rate of the application would be, so many milliliters per plant. We'll see that on the treatments editor. That's an option for our rate unit is amount of liquid or grams per plant if it's a dry formulation, but the amount is per plant is how you're applying it. Then you can have the application amount be mils per item. So the word item is vague enough to cover plants per seed if you were to do seed treatment or something of that sort. So mils per item can be used for particular rates, like a rate per plant. And then let's just choose that one real quick here, just to see that then the mix size calculator, there's no mix size because it's just per plant. So just depending on the choice of that application amount unit, then ARM will kind of understand that type of application and kind of lead you to the right choice there of what you might need for your mix size or none at all. So we'll stick here. For our example, I'll just stick to the 0 application amount since we're really dealing with the concentration and we really don't have a specific amount that needs to be applied to the pot, in this case, to that plant. So what we will do then, in this case, is we'll want to specify how much we're gonna mix up. So for example, maybe I have a 2-liter jug that will be used, and I'll pretty much almost fill it up with water, and then I'll ask ARM to tell me how much of my formulated product I should put into that 2-liter jug to mix it up to give me the right concentration that I need to apply onto that plant. So you can, instead of dealing with the whole calculations here, we can just specifically say this is the equipment, if you will, that jug that we're going to utilize to make the right concentration for our treatment. In this case, we'll say I've got a 2-liter one we'll want to use. So that fills in that information here for us. Now we can move over to the treatments. And since we chose the split plot, you can see that we have our treatment editor is set up a little different, a multi-factor design. We will be describing the 2 factors that we have. But really it's kind of the same as a regular treatment editor as far as each individual component. You can have multiple components for a particular treatment, or in this case, a particular factor level. And when we're all done and create the trial, we'll combine variety 1 with concentration 1, variety 1 with concentration 2, etc. So I just going to put in some real brief information. Our first concentration is actually untreated. We want an untreated check with 0%, if you will, depending on what you'd want to call it. And then we said low, medium, and high concentration. And then the variety, we just had one that was the resistant, and then also one that is susceptible, if I can even spell that correctly. Hopefully that's close. So with the variety, there's not a whole lot of treatment information that we need to fill in. But here for the concentration is really where we want to focus. And so for the treatments and really for the application as well, as we saw in some of those lists, there's a lot of options and there's a lot of possibilities in how ARM is structured and able to convert information to give us the calculations we need. So it's really kind of just all about figuring out how to make it work in ARM. Like I said, we spent probably an hour and a half figuring out this concentration example of how best to use the information we have, of how the study needs to happen. Okay, what's the best way to put that into ARM so ARM can calculate what we want to know. So for this concentration study, our example here, the approach we took was to put in the formulation concentration was really the starting concentration we had of our, in this case, it was the fusarium that we were mixing up. And so we would start with 100,000 CFUs per milliliter. You find in my list CFU per milliliter. And the formulation type, it was a liquid. Could be more specific, but that'll give us all we need. So the formulation concentration is really, I would say, the base level, that base concentration of what we start with, what we either take out of, we get the jug from the sponsor, or if we had to make it up ourselves, what was the highest level we were starting with, and then planned to dilute further as we went. So maybe I'll hear in a little description that low we'll say is 10%, then the medium is maybe 50%, and the high is 75%, or whatever. And the untreated would really be effectively 0%. So that's really the dilution we are trying to achieve. So let me just copy that information into these other rows. Yes, I want to paste that in. Technically, we could do it for the untreated check, but really we wouldn't have to. So then the base amount being the 100,000, then we want to, in the rate, in our case here, just looking at the rate units, quite a few options, but you'll see when we were trying to figure this one out, we started with the CFUs, but we were finding that really most of those rates were per area or per seeds. For a seed application. So we really didn't have an option to specify per plant or what's the basis. In our case, not having a specific amount that we'd measure out to make sure that exact amount was applied to the plant. It was just a matter of covering the plant and being consistent in how much we covered each plant. Then we struggled to find a unit that would match. So that's why we took the approach then, well, we can't put the CFUs in the rate, so let's put the CFUs in the formulation. And then in this case, we relied on the percentage. So instead we did a percent volume to volume on the rate unit. And now we can put in simply our percentages of what we wanted from that main amount of the 100,000 we were starting with, and simply put our target percentage. I'm just using the single quote to copy the value right above me in that table. And I guess if I want to be very explicit, I could even say it's 0% for the rate, or I could leave it blank since it's the untreated check. So again, it was kind of a matter of looking at the options within the rate unit, our options in the formulation unit, to come up with the right way to describe what we were doing. And so just to show then in the print reports, if we create the protocol spray seeding plan, I'm going to, actually, I was going to preview this. I recall now I've got a multi-factor design, so it's going to want me to save this protocol in a multi-factor study. It kind of creates, it has to kind of create that multiplied out treatment list in the background and then generate the report. So this will save me a step if I do that first and then generate the report preview. We got some grouping options since it's a multi-factor design. We won't go into that too deep. And if I zoom in a little bit, we'll just see the full treatment list. So you'll notice now we've got that multiplied out for the untreated will be applied both to the resistant and the susceptible varieties. And then we apply the low concentration to the resistant, low to the susceptible, et cetera, et cetera. So we get each combination. And as we go over the amount of product to measure now, we have the number of mils, the amount of liquid that we'll need from that 100,000 CFUs jug that we have. We'll need to measure out, in this case, 0.08 mils and put that into our mix size of, well, this lists a very small mix size. So I don't know if I didn't check something quite right. Oh, we didn't link it to an application code. So since I didn't put my application code, it's using the options and settings. So I would explain why that number is terribly small. I needed to link these treatments to their application code, because without that, then they fall back to the settings. So real quick here, we'll just go back there just to see that should change those calculations. Not that those numbers probably mean anything to us at the moment, but proof of concept at least that you need to make sure to link your treatment components to the application code or more than one code. There, that's probably a little bit more attainable measurement that we can make, 200 mils to put in to that mix size of our 2-liter jug in order to obtain our 10% concentration. And then kind of following suit, just a shade under 1 liter, and then 2/3 of a liter to get that concentration amount that we want. So I guess that's the example here for kind of a concentration. I think just depending on the type of study you're doing, hopefully if you have that same pattern of a concentration you need to create, this would kind of provide a format for that. Like we said at the outset, definitely if you are trying to figure out the best approach for making what research you're doing kind of work in ARM and give those calculations, let us know. It'd be a great challenge. Help us understand how ARM can be used, and if we are missing a component, then that's something we can bring to our programmers and say, hey, we're just missing this particular tool or this functionality, and ARM could be used in these types of studies. And that's a great way for us to find new features and things to build into ARM by getting those questions. All right, last section of the protocol before we move on to that trial map would be the assessment data. And specifically within a protocol, really the assessment headers describing your assessments. And I would say in this case, this is probably the close, for a greenhouse study, the closest match to a field study, just as far as the process for defining headers. You know, there's not a huge difference. Certainly the way you're performing the assessment, maybe the types of assessments you're doing are different. But just from an ARM perspective, you know, utilizing the software to describe the assessment, it's still kind of the same principles would apply. So just to recap, maybe the real basics that I like to highlight in a beginner training of what's absolutely critical would be these three fields here for the part rated, the rating type, and the rating unit. Those really create the core of what is it that's performed. Or, you know, as you're writing your protocol, what do you need to perform as an instruction for the trialist. And so, you know, the part rated would be specific to, you know, what is the object that you're looking at or performing an assessment upon. So instead of just saying it's the plot itself, it's the experimental unit, well, which part of the plant? Is it a specific part of the plant that you're going to look at? Is it a particular aspect of the pest? So you can also, that's kind of the other half of the part rated, you have the actual object. That list is kind of a list of objects that are the focus. And then this second component to the part rated is C or P to refer to either the crop or the pest. So which are we looking at? Here in our our disease example, probably looking at the crop to see how it's responded, but certainly if you're looking at bugs or if you're trying to rate how severe the disease is, then it would be the pest. So just depending on you select the object, and then you can clearly specify, are you referring to the crop itself, or are you referring to the pest? And then the rating type, that is the what. I like to say that is the action performed. Are you counting something? Are you rating the damage? Whatever kind of the action that is performed in the assessment is the rating type. Then the rating unit is when you fill in a value. In that trial, you'll have the experimental units underneath. When you go to write down the value, what is the unit of measure of that value? And so that is really the rating unit. If you're doing a count, it doesn't have a unit, it's a count. So I like to recommend the choice of using number for a count, where there's kind of a unitless value there, then choose number. So that's in general, it really tips for filling in the assessment. In general, I would say maybe for greenhouse studies, perhaps subsampling could be maybe more common. I don't know, I guess comparison wise, but subsampling can be important. And so just to highlight those fields, I'm going to go into my hidden fields and turn on the sample size, collection basis, and reporting basis. So there's really I would say these 4 fields can be used to describe subsampling. I won't go through all the details as we're getting close to the end of our hour. But I will just point out that in the help menu, we have a reference PDF for describing subsamples in assessment data. Oh, and now that moved my screen entirely here. So just to point out that'll open up a PDF document that just walks through a few examples. When you don't have any subsamples, it's just a one. A simple example of subsampling utilizes the sample size. If you want to really detail the subsampling technique, you can leverage the collection basis as well. And if you're going to normalize the data, that's where reporting basis can come into play. So have a look at that example, or examples, I should say. Let me toggle back over to this window here, and just to see those different examples of how to use those different fields. There's a lot of capability to it, as you just kind of have to learn exactly what each of those means. What's the goal of that field? But it can be real powerful to be very specific about what needs to occur, or documenting what you are doing, depending on which side of the protocol or trial you're on. All right, I'm going to hit save here and go to create a trial then. Say that's the last major component. Oh, it doesn't like my treatment type. I had thought when I first came there that was unusual. It tried to fill in from our settings when we had described our factor level. And so it tried to fill those in. If I pick from the list, it will show me the list of valid treatment types. Instead of picking from the list, I just type things in. So I'm going to edit and clear those out. I could pick the right type, but for time's sake, I'm just going to clear them out and now try to create the trial. Oh, and then of course I'm overlooking the fact that I have the same problem down here, this treatment type. There we go. All right. Okay, no more validation errors, so it should allow us to go. Greenhouse webinar, I forgot to put in a trial ID. Of course, that's one of the first things you would do when you actually create a protocol is plan out the IDs. All right, so when we go to create a trial, of course, it's going to give us our trial map. It's displaying something a little weird for me. Let me see if I can just turn off some of these display options to simplify our map for us. All right. That's a little better. Let me try to expand this. I've got my smaller screen, so that doesn't always help us. Maybe now we can show the factor level because that will be somewhat important to us. It just gets it kind of small, but we can zoom in a little bit. Yeah, I don't think it likes the weird resolution I'm running at to make it easier to show, but that's okay. So the trial map, of course, is just a little bit different approach to the map than you would in a field. Of course, the field is the field, and there are own block size and considerations to get the plots where they need to be in the field. In a greenhouse, you maybe have a lot more say as to how things are arranged and where things go. And really the plot map then would essentially just be the arrangement of your experimental units on the bench or on the tray or wherever these experimental units are going to be placed. So you'll still have that two-dimensional space. Maybe it's 3 dimensions, and you have to use your imagination a little bit that maybe each row here is actually a different tray, vertically in the greenhouse. So it might not always be on the same plane, but hopefully you can still, put in the trial map to describe how the experimental units were placed. That's really the goal of the map here. I guess a slightly different target with the same goal in mind of making sure that the arrangement of the experimental unit in the trial matches what we have described here in the trial map. So we showed that split plot design we had chosen specifically in order to arrange these the way we wanted. And so you'll notice we have things paired up. So our A1 are next to each other, which matched. If I peek into our level description, the A1s are the untreated, and then the A2s will be our low concentration, medium concentration, and high concentration. So as we said in our design for this particular study, we did care where we put the plots. That we didn't want to have the untreated that had no disease given to it. We wouldn't want one to be right next to the high concentration if we were worried about any drifting or impacts that may have. We want to kind of keep them separated. And maybe each of them would be on separate trays or however we would arrange it to make sure that we don't have any unintended consequences from that. So we chose split plot so that way ARM gives us this pattern, if you will. So it put the A1s together within each replicate. So let me color by replicate just to see that. In this case, with the split plot, it is a randomized complete block, which again, may or may not really apply to us much. But here we can see then we're putting replicate 1 all in a block, and then replicate 2, replicate 3, replicate 4. So that's the arrangement of the trial. But because we kind of wanted a trick to get these all together, we chose that split plot. And so those two are together within the replicate. The A4s, the high concentration, are together, etc. There is a trick. So of course that worked great in one replicate, but now in the other replicates, the choice of where those pairs go can be different. So we do have an option if we go to our settings, and here we're on our layout tab. So this will control a lot of how the map is put together, how it's numbered. If you want to specify spacing between the experimental units, there's a lot of options to do that here. But specifically for our example, do not randomize one unit. I can say I don't want to randomize the concentration. And so it's going to re-randomize that for us. And this time it's going to put the A1s next to each other, both in the first slot in each replicate. Then it's going to put the A2s next, then the A3s, then the A4s. So we said within each replicate, this first row here is one replicate. I want to not randomize where the A1s go versus the A2s, et cetera. Put them all in the first slot, second slot, third slot. And now each replicate has the same pattern across the way. They will all start with the A1s. So now we have all the A1s together in one section. Maybe this will be one tray even, and then this will be a separate tray to keep them separate. However, they'll live in the real world. So that's a usage of the split plot for how you may arrange them if you had a specific reason to arrange them. Real quickly, I'll see what happens. I don't know if it'll get mad at us if I try to switch the design up to a CRD. We'll see if it freaks out because we're in the middle of creating. Oh yeah, it's deleting treatments. Let me cancel that. That didn't like us doing that. Of course, this would be a choice we would want to make back in the protocol. So let me just come back to the settings here real quick. Design, if we set it to CRD, that's why it wanted. So we do have 6 treatments now Now, if we go to randomize, just to highlight what that completely random design would give us, we have full flexibility. Now we're just coloring by treatment number. We have full flexibility in where treatments can appear. So it looks like we ended up with our treatment 5 is marked as untreated, which isn't quite right. But those ended up in the first 2 rows and none in the second 2 rows. There is no blocking that has to happen. Any treatment can occur anywhere in the map because we're not concerned about the placement on the tray, and it can be totally random. So that's where the benefit of the CRD, that's the CRD design would give us. Kind of the same thing for the factorial CRD. It's really going to be the same thing, just with that extra functionality of having the factorial arrangement of the treatments and planning out the treatments that way. The map will still have this same approach that doesn't matter where they end up. There's no blocking. There's no rule of having to have one treatment in each row or anything like that. They're free to be placed wherever. And you can simply just, if you don't quite like that dispersion, if you kind of still want them dispersed somewhat, simply, I'll just hit re-randomize and have it generate a new randomization for me until I find one I like. And there's some quality features here. If you were wanting to make it nice and distributed, there's some functions here at the bottom to kind of help with that, quantify how spread out they are. And like I said, if you don't like what you see, just hit re-randomize again until you get one that is nice and distributed. All right, well, we've reached the end of our hour. I have a few minutes. If anyone had questions that they were holding on to the end, I can certainly hold on, but I don't want to hold anyone hostage either. So I want to thank you all for attending today. And again, just encourage you once more to reach out to us if you have a particular challenge where your greenhouse study, it's not going into ARM as easy as you'd like. Get a hold of us and we can kind of work through it and see the best way to get it in there. Again, don't be a stranger. Hopefully we'll see you again soon, maybe at another webinar. We've got a couple more in the next week or so that maybe we'll get to see you at. So thank you, everyone.